Quiz 3 in week 3 was on inductance in AC. That's chapter 17 in the 6th edition. This is a Microsoft Word document with the same exact questions and answers that's in D2L, so I'm going to use this as our quiz review. Number 1, how many degrees are the current and voltage out of phase with each other in a purely resistive circuit? 0 degrees out of phase. They are actually in phase in a purely resistive circuit. Number 2, how many degrees are the current and voltage out of phase with each other in a purely inductive circuit? In a purely inductive circuit, current and voltage are 90 degrees out of phase. Number 3, to what is inductive reactance proportional? To illustrate this, I'm going to write the formula. So this is inductive reactance, X sub L. 2 is the number 2, pi is the number pi, 3.14. Frequency of the line and inductance of the inductor. Those are the two things that inductive reactance is proportional. So the correct answer is both the inductance of the inductor and the frequency of the applied voltage. So in D2L, there's an answer that has both of those answers, correct answers. What is the unit of measurement for inductive reactance? Inductive reactance is, again, the current limiting thing in an inductive circuit, so it is measured in ohms. Number 5, 3 inductors are connected in series. Here we have their values. True or false, the total inductance LT of the circuit is 1.64. That is false. To get total inductance in a series circuit, we simply add them up. Equals 3 plus 6 plus 9 equals 18 henries. So the answer is false. Number 6, the induced voltage on a coil is proportional to the rate of change of current flowing through the coil. That is true. The induced voltage requires a change in the current flowing through the coil. So this is a true statement. For number 7, we were given these two formulas here, and we're going to need both of those to solve for this problem. Number 7, an inductor is connected to a 277 volt 60 Hertz line. The circuit current is 1.2 amps. Knowing that we can substitute X sub L for R, or resistance, in Ohm's law in a purely inductive load, what is the inductance of the inductor? So we're looking for L equals what? So first we need to figure out what the inductive reactance is, and for that we can use Ohm's law. This is basically Ohm's law here. Voltage over current. We're given 277 volts. We're given 1.2 amps. We do the math and we get 230.8 ohms. Now we can use this formula here to solve for L, or solve for inductance. We can see that formula here equals X sub L over 2 pi f. If we do that in math, plugging in 230.83 for X sub L, we get this answer here, 612.3 millihenries. This also equals 0.6123 henries. Number 8. A 4.2 Henry inductor is connected to a 120 volt 50 Hertz line. How much current will flow in this circuit? I underlined 50 Hertz because that's sort of an unusual frequency for us here in the US, where we are more accustomed to 60 Hertz. So be careful when you see, when you read the problems in quizzes and exams. So we're solving for current. So the first thing we're going to do is figure out what inductive reactance is. Again, inductive reactance is the current limiting thing in an inductive circuit, and we know the formula X sub L equals 2 pi FL. When we do that math right here, we get 1,319 ohms for inductive reactance. And now we can use Ohm's law. But we're going to substitute X sub L for R. That's what this part here is. We're given 120 volts. We just solved for inductive reactance, and we get 0.091 amps, which equals 91 milliamps. For number 9 and 10, we're given this formula here. Number 9, a coil has an inductive reactance of 120 ohms and a wire resistance of 3 ohms. What is the quality, or Q, of this inductor? We have that formula right here. It equals, I'm just going to rewrite it here, X sub L over R, or inductive reactance over the internal resistance, 120 ohms divided by 3 ohms. Our quality is 40. And finally, number 10, an inductor has a wire resistance of 9 ohms. The Q of the inductor is 12. What is the inductive reactance of the inductor? So we're solving for X sub L. We have the formula. We were given Q equals X sub L over R, but we're solving for X sub L. So doing a little bit of algebra, we get X sub L equals Q times R equals 12 times 9 equals 108 ohms.